This is the Chapter 4 review for the final exam, or in general. Chapter 4 dealt with trig, so we're going to look at converting between degrees and radians and degrees, basic right triangle trig applications, angle of elevation, angle of depression, 6 trig functions, reference triangles, and the unit circle. The unit circle will be a separate video. So first let's convert between degrees and radians. Let's say we have a convert we're going to convert 45 degrees to radians. Degrees to radians, the conversion is pi radians in the numerator, 180 degrees in the denominator. Since you want to get rid of degrees and pick up radians, you must put degrees on the bottom, radians up top. 45 degrees times pi radians divided by 180 degrees. Use your calculator. Remember, do not type in the pi, otherwise it'll calculate the pi into your final answer. The degrees do cancel out. 45 divided by 180, 0.25. Remember how to convert. You go math, fraction, enter will give you a fraction. So now I will put the pi back in. So this is pi over 4 radians. You could have also written 1/4 pi or 1 pi over 4 radians. It's all the same. This time let's convert between radians and degrees. So you had 7 pi over 9 radians, and you wanted to go to degrees. The conversion this time is flipped. Since I want to pick up degrees, I'm going to have degrees on the top and pi radians in the bottom. So 7 pi over 9, this is rads, times 180 degrees, pi radians in the bottom. The radians cancel. The pi's in this case cancel. Sometimes the problem has the number already multiplied in with pi. In that case the pi doesn't cancel, and it would be in your final answer, or you would divide out the pi. So look out for those. Now it's just calculator, 7/9 times 180. So we're looking at a 140 degree angle. Alright, we also looked at converting to degrees, minutes, and seconds to decimal. Convert degrees, minutes, seconds to decimals, and vice versa. So let's go to the degrees, minutes, and seconds to decimals. Let's say you had 47 degrees, 38 minutes, 41 seconds. My suggestion is you think about time. Time goes in increments of 60. Start at the very last digit, 41. Convert that first, divide that by 60. If you take 41 divided by 60, that's going to give you a fraction of a minute. So now you have 47 degrees, 38.683 minutes, because 41 seconds is 0.683 of a minute. Take this answer, 38, and divide that by 60. So your answer is going to be 47 degrees, 0.6447 degrees total. So that's your answer as a decimal. The other way to think about this number is you could do this all in one step. 47 degrees, 38 minutes, 41 seconds. If you think about each one of the individual conversions. So this is 47 plus 38 over 60 plus 41 over 3600. In a second, how many degrees are there in a second, or how many seconds are there in an hour? That's 60 times, so 60 times 60 gives you that. So if you take this same answer, you get the same thing we got originally. It just requires you to remember a little more about seconds. If you're going the other way, convert a decimal degree to degrees, minutes, and seconds. 51.472 degrees, and I want to go degrees, minutes, and seconds. So we know we have 51 degrees. Now we're going to work backwards, so now we're going to multiply. 0.472 times 60. You want to know what fraction of a minute that is. So far we have 28. We just take the whole number. Well, let's take that decimal and do it again. So we take the decimal from that last answer, and we get 19.2. Seconds will have could have the extra decimal there. Minutes should not. So in this case, we're going to multiply by 60 twice. Scroll up and see what we have next. Right triangle trig. So let's look at basic right triangle trig. The key to right triangle trig is knowing where your reference angle is, where you're looking from, and what are the parts when you're looking from that angle. So you need to know, where am I looking from? You have an angle theta. From theta, you have opposite theta, because you're across from theta. You have next to theta, which is adjacent, and the hypotenuse is always across from the right angle. If you change your point of view, call this angle x. From angle x now, opposite, adjacent, hypotenuse is still the hypotenuse though. But O is going to be opposite, so you're looking across, that is opposite. Next to the angle, side that is not the hypotenuse is the adjacent. Remember SOHCAHTOA, S-O-H, C-A-H, T-O-A. These are your ratios. So if you're looking at the sine of x, is OH. Cosine from angle x is AH. Tangent from angle x is OA. So now the types of problems you're going to get some kind of a triangle. Orientation doesn't really matter. We'll say angle theta. And we'll plug in some information about angles. Let's say we're looking at a 3, 4, 5 right triangle. So this is 3, 4, and 5. So the sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. if you're trying to solve any one of these for theta, you'd have to get rid of the sine, the cosine, or the tangent. So in order to solve for theta, doesn't matter which one of these ratios you go with. Let's just take the cosine. Is 4/5. So in order to get theta by itself, you have to undo cosine, which is called the arc cosine, at 4/5. In your calculator, make sure you're in degree mode. So we'll check the mode. Currently it's in radian. Change that over to degree. Exit there. Clear out my screen here. So I want to go second cosine of 4/5. Because you're looking for the size of the angle that makes theta. So the angle theta is 36.87 degrees. Works the same way for any of the other ones. If you went tangent, the arc tangent at 3/4 gives you the same thing. Arc sine at 3/5. Those all give you the same answer. It's all the same angle. You need to know where it is you're looking from in order to solve those. The other type of problem that you could get for a trig problem, regular trig ratios, you have an angle that's 42 degrees. You know that the opposite side is 12. How long is the hypotenuse? Or how long is the adjacent side? So you could be asked about either x or y. So you choose. Let's say we solve for x. So figure out what ratio you're looking at. I want to know x. So I'm looking at the side opposite and the hypotenuse. So the sine of x is the opposite over the hypotenuse. But I know my angle. In this case, the angle that I know is 42 degrees. So the sine of 42 is 12 over x. So I need to solve for x. Multiply both sides by x and divide both sides by the sine of 42. So x is 12 divided by the sine of 42. Again, make sure your calculator is in the correct mode. Type this in your calculator, 12 divided by sine 42. It says x, the hypotenuse, is 17.934. Alright, let's change color and solve for y. We could solve for y using Pythagorean theorem, since now we know x and 12. But we're going to use trig to solve for y. Y is the adjacent side when you look at it from 42 degree angle. So cosine of 42 is the adjacent over the hypotenuse. In this case, we know that's 17.932 because that's x. Or similarly, if you didn't know x, you could have gone with tangent. Or tangent of 42 equals opposite over adjacent, 12 over y. To solve, if you're using the cosine, multiply both sides by 17.9. Cosine of 42 equals y. So 17.932. Cosine of 42, because we're looking at a 42 degree angle, gets y as 13.326. Similarly, if we solve that same problem for y with the tangent, 12 divided by the tangent of 42, we should get the same answer. So we get the same answer relatively. Those are your two types of right triangle trig problems you could get. I will scroll back down in a second. Trig applications, angle of elevation, angle of depression. So angle of elevation, angle of depression. Say we are on a lookout tower. We spot a ship or a boat out on the water. The angle of depression to the ship is a 35-degree angle. Now remember, with angles of elevation and angles of depression, they're the same thing. The person looking down at the ship is the same as the person on the ship looking up. Angle of elevation and angle of depression are the same. They are alternate interior angles from a parallel set of lines. The horizon and the ground in this case, or the ocean. Let's say the height of the tower is 250 feet. How far is the boat? So my 35 was my angle of depression. And remember, like I said, that is the same as your angle of elevation. The angle of depression is never in this blue area. This blue area here is never your angle of depression. It's always the angle that's down at the bottom at the base. Alright, so we need to find out how far the boat is, so I don't know how far that is. Opposite and adjacent. So again, we're looking at a tangent. 35 degrees equals opposite over adjacent. Multiply by x and divide by the tangent of 35 degrees. Your calculator is already in degree mode, so 25 divided by the tangent, oh sorry, that's 250, divided by the tangent of 35 degrees. So x, the distance, is 357.04 feet, more or less. Elevation and depression problems are basically the same. 6 trig functions. So you have 6 different trig functions you can come up with. We already know about SOHCAHTOA. Sine, theta, OH, cosine theta, adjacent over hypotenuse, tangent of theta, OA. Those are the first 3 ratios. Next 3 are connected. Cotangent of theta is the reciprocal of tangent. AO. Secant is the reciprocal of cosine. HA. And cosecant is the reciprocal of sine. So again, if you're given, let's go with our 3, 4, 5 triangle, and you're given your angle theta, you can find all 6 trig ratios the same way you did with the first 3. OAH. You just fill them in. Sine, 3/5, 4/5, 3/4, 4/3, because now we're looking at the reciprocals, 5/4, 5/3. Your calculator does not have those bottom three functions, which I'm going to highlight here. Calculator does not have these bottom three functions. Doesn't mean you can't use them. It just means you have to go 1 divided by the sine, or 1 divided by the cosine, or 1 divided by the tangent. This is 1 over sine, that's cosecant, 1 over cosine, and 1 over tangent. Should you ever need to put those in your calculator, that's how you do it. Okay, reference triangles. Same thing as right triangle trig. This time we're going to give you a point in space, -3, -5. And you want to know all 6 ratios from that point. First you need your coordinates. -3, -5, so back 3, down 5. Somewhere like this. Draw a line back to the origin. That's the first side of your triangle. And now the second side is always drawn with the x-axis. So you're always going either up or down to the x-axis. You went left 3 and down 5. Those are the only two ways you can get a negative. If you go left or if you go down. Hypotenuse is always positive. Hypotenuse is going to be 5 squared plus 3 squared, so 25 plus 9. That's going to be 34, so this is the square root of 34, and the hypotenuse is never negative. Going left is negative, going down is negative. Make sure your coordinates match your directions. Left, down, left, down. Sine theta, and your angle theta is always your reference angle closest to the origin. OH. You could rewrite this without the square root in the denominator, -√34 over 34. Or you could leave it with it in the denominator, doesn't make a difference. Cosine theta, A, over the square root of 34. Tangent of theta is OA. -5 over -3, which we all know makes it 5/3. Cotangent is the reciprocal of tangent. Secant, reciprocal of cosine. Cosecant, the reciprocal of the sine. Please notice that cosine, the reciprocal is √34 over -3, reciprocal of sine, √34 over -5. Those are all the same from there. Figure out where you are, draw your triangle with the x-axis. So those are your reference ones. Next we're going to look at the unit circle. So for the unit circle, if you remember the first quadrant, cosine, sine are the way the coordinates go. Keep in mind that your reference dots are all connected. Once you know the first quadrant, you just have to follow along and find each additional quadrant. √3 over 2, 1/2. √2 over 2, √2 over 2. 1/2 root 3 over 2. First angle, change color. This is a 30-degree angle. So for example, if you take cosine or the sine of 30, you get 1/2. Next one is 45. The next one after that is 60. When you're up at the top, 0, up 1. Now you just start connecting. Negative 1/2 because you went left, root 3 over 2 because you went up, left, up, left, up, negative 1 comma 0. Now you're going to connect downward. These are all connected as you go around. These are both negative because they're in the fourth quadrant. Negative root 2 over 2, negative root 2 over 2, negative 1/2, negative root 3 over 2, and then finally they connect across again. 1/2 because you're going right, negative root 3 over 2, root 2 over 2, negative root 2 over 2, and finally the last one, root 3 over 2, negative 1/2, complete your circle. Now remember, when you're counting, you're going to add 30 for that first step. So this is 90 plus 30, that's 120. Add 15, 135. $150, $180 because you're adding 30. Add another 30, $210, $225. Add 15, $240, $270, $300, $315, $330, and finally $360. Alright, so let's look at this. You're cutting up a 2 pi into individual chunks. Now you're going to cut these pies into smaller and smaller chunks. So let's count them as sections of 12, because there's going to be 12 in half of a pie. So the first one we don't count. That's 1 pi over 12. This is your second pi over 12. 3 pi over 12. 4 pi over 12. 5 we skip. 6 we don't. So this is 6 pi over 12. We'll come back and reduce them in a minute. 7 we skip. 8 pi. 9 pi over 12. 10 pi over 12. 13 we skip. I'm sorry, 11 we skip. 12 we pick up. 12 pi over 12. We keep going. 13 skip. 14 pi over 12. 15 pi over 12. 16 pi over 12. 17 we skip. 18. 19 we skip. 20. 21. 22. This is pi over 12. These are all pi over 12s. 23 we skip, and this is 24. When you simplify, you'll get your desired result. So 4 pi over 12 is pi over 3. This is pi over 4. This is pi over 6. Pi over 2. So you just go around and reduce those, but that's how you think about it. You got to put 2 pi, because that's a big one. First one you skip, next one count, 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 skip, count, skip, count, count, count. So just keep going around. You're counting by 12s. First one skip, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. And then reduce them from there. The other one you need to know is the tangent is sine over cosine. Sine over cosine. This is 1 over the square root of 3. This is 1. This is the square root of 3. And then they connect from there. This is a very messy one. Look online. There is a neater one. Or look on the sheet that I'm going to put up. There is a cleaner version of this. But that's how you generate it. That's how you use it. All right, that's chapter 4.